Welcome to the DX Today podcast, where you get the facts and no hype.
Great to be here, Alex.
Today, we are unpacking a massive shift in the technology landscape. We have spent the last few years talking about the capability of artificial intelligence, what it can do, how it writes code, how it generates images. But looking at the data from 2025 and moving into 2026, the conversation has fundamentally changed. It is no longer just about capability. It is about consequence.
That is exactly right. For a long time, AI felt like magic because it was software.
It lived in the cloud, which sounds fluffy and intangible. But 2025 was the year the curtain got pulled back. We realized that the cloud is actually acres of massive servers, gigawatts of electricity, and billions of gallons of water. We are seeing AI reveal itself as a heavy industrial machine. It paints a pretty stark picture. Let's start with the energy consumption. The numbers here are staggering. They are. Scarcity, the projections we are seeing now suggest that could hit 12% by 2030. That is a tripling of demand in just 6 years.
Globally, if you look at the IEA data center consumption is heading toward 945 terawatt hours by 2030. To put that in perspective, that is roughly the entire electricity consumption of Japan.
That is massive. But I want to dig into why this is happening now. We've had data centers for decades. What changed in the last 24 months to cause the spike?
It comes down to the difference between a traditional Google search and a generative AI query, 0.003 kilowatt hours.
But when you ask a generative model to write a summary or create an image, you are burning 10 to 30 times more energy. And if you are using those complex reasoning models, like the O1 or O3 series from OpenAI, it can be 100 times the energy cost of a standard search.
And people aren't just doing this occasionally. It is embedded in everything now. Word processors, phones, search engines.
Exactly.
Right. Historically, all the headlines were about how much energy it took to train a model, like GPT-3 or GPT-4.
Yes, and training is energy intensive. Training GPT-3 used about as much power as 120 homes use in a year. But that is a one-time sunk cost. Once the model is built, you are done. That is the act of actually using the model. Every time you ask a chatbot a question, that is inference.
The report notes that inference now accounts for 70 to 90% of the lifecycle energy of these models.
That is the game changer. It is the always-on shift. You train the model once, but you query it billions of times. We are also seeing the Jetsons paradox in action here. As these models become slightly more efficient, we don't save energy. We just use them significantly more, so the total consumption skyrockets.
So we have this massive demand for power. But the report also highlights a second crisis that gets a lot less press: water.
Water is the silent footprint. Most people don't realize that data centers are thirsty. They generate immense heat, and the cheapest way to cool them is evaporative cooling, essentially giant cooling towers that evaporate water to remove heat.
I was shocked by the metric in the report.
A typical conversation with a chatbot, about 20 to 50 queries, consumes roughly 500 milliliters of water. That is a standard water bottle, gone, just to answer a few questions. Multiply that by millions of users daily. Alone, data centers consumed over 17 billion gallons of water in 2023. We are seeing massive community resistance.
Let's talk about that resistance. The report mentions that $64 billion in data center projects have been stalled or blocked. That is a huge amount of capital sitting on the sidelines. It is unprecedented.
In 2024 and 2025, we saw residents in places like Oldham County, Kentucky, and even down in Chile successfully block multi-billion-dollar facilities. The primary driver wasn't power, it was water scarcity. The social license to operate is expiring.
So you have a power crisis and a water crisis. The tech giants, the hyperscalers, have to solve this to keep growing. The report identifies a few major strategies they are pivoting to. The big headline grabber is nuclear.
The nuclear pivot is the most significant industrial shift we have seen in the sector.
You can't run a data center on just solar and wind because they're intermittent. The sun doesn't always shine, the wind doesn't always blow. AI needs baseload power, 24/7 reliability. Nuclear is the only carbon-free source that provides that.
And we saw this with the Microsoft deal, right?
Exactly. Microsoft signed a 20-year deal with Constellation Energy to restart Unit 1 at 3 Mile Island. That is symbolic and strategic. They are essentially becoming utility patrons to guarantee their own power supply.
We are also seeing Amazon and Google investing heavily in SMRs, small modular reactors, hoping to bring those online in the early 2030s.
While they wait for nuclear, what is happening with the hardware itself? You mentioned the heat earlier.
The hardware arms race is forcing a change in physics. The new chips, NVIDIA's Blackwells for instance, are incredibly dense. A standard server rack used to draw about 10 kilowatts. Now, these AI clusters are drawing over 100 kilowatts per rack. You literally cannot cool them with air anymore. It is physically impossible.
So they have to move to liquid cooling?
Yes, direct-to-chip liquid cooling. It is more expensive up front, but it is actually better for water usage in the long run because it is a closed loop. You aren't just evaporating water into the sky.
There is another interesting case study in the report about what is happening in the Nordics, specifically Finland. They are taking a circular approach.
This is one of my favorite examples of innovation. In Helsinki, Microsoft and Verne Global built data centers specifically to plug into the district heating network.
So the waste heat from the servers heats the city?
Exactly. Instead of venting that heat into the atmosphere, they capture it and pipe it into homes. In a cold climate, this turns an environmental liability into an asset. It is actually helping Helsinki displace coal and peat for heating.
That is smart, but it seems limited to cold climates. You can't really do that in Texas or Arizona.
True. In hotter regions, the focus has to be on water conservation and grid stability.
Speaking of grid stability, the report mentions the regulatory environment is heating up.
It is not just about building permits anymore. Governments are getting involved. We are seeing the regulatory hammer come down. In the EU, the AI Act fully kicked in August 2025. It mandates transparency. Companies can no longer hide their energy data. They have to report it. Here, there is the proposed SHIELD Act. The concern there is consumer protection. Utilities are spending billions to upgrade the grid for these data centers, and policymakers want to make sure your grandmother's electric bill doesn't double to subsidize a tech giant's AI model.
So, for the enterprise leaders listening, the CIOs and CTOs who are buying these services, what should they do? The report has some specific recommendations.
The first thing is to stop buying blind. Ask for the carbon intensity and water intensity of the specific region where your workload will run. All clouds are not created equal. A server in Finland is much greener than a server in a coal-heavy region.
And what about the models themselves?
This is the most actionable advice. Right-size the model.
We have this tendency to use the biggest, smartest model for everything. You don't need GPT-4 or a massive frontier model to summarize a meeting note or classify an invoice.
Use a sledgehammer to crack a nut.
Exactly. The report strongly advises moving to SLMs, small language models, things like Llama 3 8B or Phi 3. They consume a fraction of the energy, sometimes 1/10, and they are perfectly capable of handling 80% of enterprise tasks.
And I imagine timing matters too.
Huge factor.
If your AI workload isn't urgent, if it is batch processing, run it at night or run it in a region where there is excess renewable energy. Don't run heavy inference jobs during peak grid hours. It costs more and it is dirtier.
It seems like the era of cheap, invisible, infinite compute is officially over.
It is. We are entering the era of resource constraints. AI is going to keep growing, but it has to decouple its growth from resource depletion. Whether that is through nuclear power, circular heat economies, or just smarter software engineering, the free lunch is over.
A sobering but necessary reality check. Mike, thanks for breaking down the report with us.
Anytime, Alex.
And thank you for listening to the DX Today podcast. Stay informed, and we will catch you on the next one.